Hello, my name is Elliott, and welcome to Better Prompting with Pseudocode. We're just going to jump right into it, get busy. I want to thank Maxim, Eric, and Dan for organizing this conference. This industry is very new, so it's really cool for all of us to get together and share our knowledge with each other like this. It's kind of a rare, cool opportunity. So thank you very much. And I'm just going to start with a little bit of a backstory. All right. So I got access to GPT-3 in the summer of 2020. And I started playing around with it and exploring its capabilities. And I was really impressed. And one of the first things that I decided to do was see if it could write code. So I figured out pretty quickly it can write code. I had it writing JavaScript functions and stuff like that. And it wasn't long before I realized like it needed a little bit of help writing functions. So I decided to help it, and I decided to use pseudocode to try to express like what I wanted it to do. And it turned out that worked pretty well, and it improved the output quality quite a bit. So I've been prompting AI language models with pseudocode since 2020, and I've learned quite a lot about it. Fast forward, ChatGPT dropped in November, and then several months later, we got GPT-4 access. And when I started playing around with GPT-4, I realized not only can this write code, but if you give it the right prompt, it can write code at the level of a human senior engineer. And that's pretty extraordinary. That's incredible. So I started using it quite a bit for AI-driven development. And around the same time, a friend of mine, Jake Brookman, tweeted about his pseudocode programming language called Jargon that he'd been using with GPT-4. And I'd been prompting with pseudocode for years, and I'd learned a lot about prompting and a lot about prompting with pseudocode specifically. So I decided maybe it would be useful if I did the same kind of thing and wrote about this programming language I've been using called Pseudoling, and wrote about that and posted on GitHub. So I did that. I went to GPT-4 and I had it help me write the specification for Pseudoling, and in the process, it even invented a new feature called function modifiers, which I think are extremely useful, and I use them all the time. So pretty cool. That worked out really well. And me and my teams have been using Pseudoling to build all kinds of interesting things, both interactive chat bots and also programs that write programs, so which we call metaprogramming, and then AI-driven development, AI-driven test-driven development. And the AI-driven development has increased the productivity of our teams so much that it has increased our output by 10 to 20x. So a 10 to 20 times increase in output. That's more than an order of magnitude. And when you're talking about an order of magnitude productivity difference, what that does for a team is it opens up new possibilities. You can start to take on way more challenging scopes, and projects become possible that were not possible before because of resource constraints. So in my opinion, this development is one of the most important things that has happened to human productivity in the history of humanity. Since the computer itself, I don't think there's anything else that even comes close to comparing to the potential productivity benefit of AI language models. And I think that pseudocode plays a very important role in that. And to explain that, first I should probably explain what pseudocode is, right? So pseudocode is kind of like a programming language, but originally it wasn't intended to be a programming language. It was intended to communicate with humans, communicate ideas about programs to other humans who may then go and implement those programs and create working stuff with them. So it turns out you can take that same pseudocode and paste it into a large language model, and it actually runs. Like, it infers the definition of things, and it can run it like a computer can run a real programming language. So now our pseudocode language is a real programming language. The specification is the code, which is pretty phenomenal. And that's how it's been able to unlock those 10x or 20x productivity increases, because the pseudocode is the code. Yeah. So why pseudocode? Why not just use natural language, right? That's a common question that I get. And turns out there's lots of answers to that question. So let's start with some of those, right? First, you get a higher percentage of accurate responses. So the percentage of responses that are correct and accurate increases by about 10 to 14%. I'm not going to cite sources here in this talk, but if you go to the Pseudoling GitHub repository and scroll down to the README, there are sources, there are papers linked in the README that show some of these findings. And these findings agree with my own findings. So the findings in the papers directionally agree with my own findings using pseudocode prompting. So very interesting stuff. I think that one of the reasons for that is because when you are prompting a language model, it's going to be contextually aware, and if you don't give it context, it will infer context on its own. So what I mean by that is, if you were to ask a language model, why is the sky blue? And then ask that same question, but with more context. So you can say, as a physicist speaking to college graduate students, why is the sky blue? And then it will give you potentially a much more detailed technical answer to the question than if you just ask it, why is the sky blue, without any context. It might infer that you're talking to a 5-year-old and give a very, very different kind of answer, right? Well, it turns out pseudocode gives it some contextual awareness for the kind of answer that you want. When it sees curly braces, then it understands that this information is scoped together. The information inside the braces is scoped together. When it sees a variable, it understands this is state that it needs to pay attention to, and then it does, right? So in that way, it is able to produce more accurate responses more often, which is extremely useful, of course, right? But again, it also has, it consumes fewer tokens. So in our findings, in converting natural language prompts into Pseudoling, we've found that we can reduce the token usage by 20 to 30%, which is pretty significant considering that tokens cost money. So in other words, you can reduce the inference cost of your program by 20 to 30% just by switching from natural language to Pseudoling or some other pseudocode programming language that is token efficient. As far as I know, Pseudoling is the most token efficient pseudocode programming language for LLMs currently, and definitely one of the richest and most robust in terms of functionality and features and stuff like that. So good choice for that kind of thing. What else? You also get better output control. And what I mean by that is you can produce templates that can be used. So let me show you an example. If we go over here, you can see this little test case description. This is a template that can be interpolated. So if we could ask it to give us written, like just natural language descriptions of all the test cases that it's going to create, and it would use that test case description in order to describe those test cases. And here it's using these things and the constraints associated with it to create unit test cases for this program that we created here. So this is the given, when, should stuff that you saw up here in the test case description. So that's kind of cool. Another interesting thing that you can do is you can constrain to a particular typed data structure. So for example, over here, I have a little robot program that uses commands, and those commands have types and they have payloads, and some of those payloads are also strongly typed. So we can see, and there's also here another example of a response template. So this is an interpolated, this is what the response is going to look like. So here is an example of the payload types. So this is a strongly typed language, and it can pay attention to those types and then produce correct outputs. So for example, if we tell it, please hand me the yellow ball from the table in front of you, our little robot first issues a command look, and it looks at the table, and then it picks up the yellow ball from the table, and then it looks at the current user and then gives the current user the yellow ball. So this is using those strongly typed data structures that we provided to it in Pseudoling. So kind of fun. So better output control, typed data structures, output templates, that kind of stuff. It's a lot harder to get things working like that using natural language, but in Pseudoling, it's really, really easy. And in fact, it's so easy that I have an easier time with it using Pseudoling than with the function, the function features built into some of the some of the large language model APIs. So yeah, it's really, really nice, and you can see it does this pretty consistently. It's really good with it. All right, so another advantage of pseudocode programming language is that we get these visual structures that indicate scopes and stuff like that, which makes it easier for both humans and AI to parse and figure out which things should be grouped together and which things should be separate, versus looking at a big wall of paragraphs of text. When it's scoped out like this, you can see where things start and where things end very clearly, which is really nice. So visual structure. We also get composable prompts. So if we wanted to, we could take the state here and these favorites here, and in fact, if we wanted to shave tokens off of this, it would actually do that, because spaces consume tokens, and as we indent multiple levels, we're wasting tokens on those spaces. So we could have specified this and even this entire state thing as their own interfaces, and then compose those into this main interface, and that's completely doable in Pseudoling. And something that would be a good optimization if we were running out of tokens with this prompt. This prompt doesn't have that problem. We're not running out of tokens, so I don't see it as a problem here. But in my larger prompts, I definitely break them out into smaller things and compose them later. So we get composable prompts. Another interesting thing that you get with pseudocode is really easy AI-driven development. So you can write something in Pseudoling and then transpile to any other language. And the power of being able to write it in something like Pseudoling, let me just show you a little example here. So there's this longest increasing subsequence algorithm that is pretty complicated. It's complicated enough that I know the algorithm, but it would take me 20 or 30 minutes to get a working implementation of the algorithm, because it's so complicated. There's lots of variables to keep track of. There's nested loops. There's lots of conditional statements that have to all be right in order for it to work, using the dynamic programming method for the longest increasing subsequence algorithm. Or you can do it in Pseudoling, and all you have to do in Pseudoling is define what a subsequence is. So a sequence derived from the source by selectively omitting elements without changing the order. And then we just give it a couple of reminders, return the whole subsequence, and remember to backtrack. And that's all we need to get it to write this algorithm and do a good job. So here we have an implementation of the longest increasing subsequence. So it turns that little bit of Pseudoling into this big function here, where you can see the multiple levels of looping iteration and then multiple levels of if statements. So lots of multiple dependent conditionals, and then more if statements at the end here, and then another loop to backtrack and build a subsequence from our dynamic programming array. So yeah, in other words, you can take something very little and turn it into something much more complex. And notice we also described told it how to do some unit testing here. This little bit I call metaprogramming. Metaprogramming is where you write programs that write programs. So this is just a little bit of a program that tells it how to write unit tests and do it with right way. And then this transpile function, interesting thing about this is I didn't define this function anywhere. This function doesn't really exist. It just inferred it. It knows what transpile means, so it knows how to do it. So we just tell it, transpile this to JavaScript with unit tests, and it does. And this is the output. And here are our unit tests that it created. So this transpiling feature, like I mentioned, has increased our productivity 10x or 20x on our teams. And I run teams that build software, and those teams are way more productive now using Pseudoling as the authoring language and then transpiling into languages like JavaScript and Python and so on. So huge wins for productivity. Okay. So AI-driven development, another great feature is that Pseudocode can democratize development because it's a lot easier to learn how to write this than it is to learn how to write this, right? So in other words, it's easier to onboard new users into software engineering and development in general, and it democratizes the industry. It makes it a lot easier for people to produce software, and I think that that's really important because talent is kind of evenly distributed around the world, but opportunity isn't. And if we can onboard more people more easily, even people that don't have necessarily the resources to find people to teach them programming, maybe they don't have good school tracks teaching programming, but maybe they can get onboarded using Pseudocode in ChatGPT or something similar. And that would be really great. That would be a net win for the world, I think. All right, so just a little bit of time left. So Pseudoling has some programming paradigms that are really interesting. It's constraint based, and you can see these are basically constraints. This is all we're telling it is the constraints. Constraints are basically just rules. You can think of it as the rule book for how to produce the output that the language model is going to produce. And those rules can be both positive, so things that it should do, and negative, things that it should not do. Constraint-based programming was inspired by Ivan Sutherland, 1961 to 1963, inventor of a lot of graphics programming things, direct interaction, VR headsets, and so on. And he's a genius. And the constraints, basically, you could say, keep these lines parallel and move things around, and it would automatically solve and keep them parallel and stuff like that. Turns out the AI language model does that really, really well by itself, and it works really nicely. And then we have interfaces, so it's very interface oriented. As you can see here, most of this program is just defining an interface. And one of the important parts of defining an interface is the commands here at the end. All right. And it's both functional and compositional, so you can compose it and stuff like that. So let's talk about why Pseudoling has the structure that it has. It starts with the preamble, which is very important for context and situational awareness. Like, what are you doing? Why are you doing it? What perspective should you speak from, right? And what is the main job you're trying to do? And that's really, really important. And then at the end, we have like the commands for the main interface and the initializer, so where it should start in its job. And it turns out these are the really, really important bits, the end and the very beginning. And that's important because we have this thing called sparse attention, that I call sparse attention, right? The paper, there's a good paper on this topic called Lost in the Middle, How Language Models Use Long Contexts. And the long and short of it is that if you exceed the attention span of the AI language model, then it's going to lose the stuff in the middle of your prompt. So it pays pretty good attention to the beginning of the prompt, which is like this bit here, which is super, super important. It also pays pretty good attention to the end of the prompt, which is this bit here, which is also very, very important. But it turns out that if it has those two things, it can mostly infer what to do in the middle. So with a Pseudoling program, if you structure it correctly, this lost in the middle program affects you less than if you structure your programs differently. So U-shaped attention, pay attention to that. That's another reason that it's really important to have fewer tokens in your prompts, which is another reason to use a pseudocode programming language like Pseudoling, because you can reduce your token consumption 20 to 30% doing it. So really nice. Yeah. So some common use cases for stuff like this. Chat UIs like this one. This one is designing an interactive friend for things like character AI or video games and so on. And what we do is we walk it through a couple of commands, like we told it, randomize a talking dog chatbot, and then it creates the state necessary to do that. And then we go in and list the elements, which is just rerunning the thing. I didn't realize I'd already done that. And then we craft the output. And this is the final output. So you can have things that get built over time in like a chat session, and that works really well. Good use case. Another really good use case is agents, because you can have different sub-agents that specialize in different things. So we use this a lot for application development. We have an agent that's really good at writing state management code. We have an agent that's really good at writing user interface components. We have another agent that's really good at project planning and project management tasks. And then we have this orchestrator agent that sees what needs to be done and then dispatches the correct agent to work on that thing. And I think that maybe GPT-4 needs a lot of babysitting when you're doing stuff like that. I think maybe the next generation will be able to, or the generation after that maybe, will be able to create entire applications from a prompt, which would be amazing, really, really amazing if it could do that. I think that is in the future. I think that's inevitable. It definitely will happen. It's just a matter of when it will happen. All right. So, and like I said, the other major use case is transpiling and building stuff. Anyway, that's about all the time we have left. I'm going to give hopefully a little bit of Q&A. And thank you all for taking a look, and yeah, enjoy the rest of the conference. Have fun. I'll see you around.